Okay, welcome to part 2 of the algorithms tutorials. You'll have to go to Canvas and download the PowerPoint again from the module. And I'll just go ahead and get started. Let's blow this up. Okay, so the first part of the tutorial, or first part of algorithms, went over this compute the number of times a pattern appears in the text. And the result of that problem, if you finish it, should be your very own pattern counting function that we put in our all functions file. So we have our own module with a function, and now we're going to put that into practice a little bit. So this tutorial, part 2, is going to work through Rosalind problem number 11. And I'm not going to give you very much code. I'm really only going to give you a couple commands that will make life a lot easier. Really just getting the max of a list and how to find the unique values in a list. I think those are the only new commands you'll need. But I'm going to walk through the algorithm, right? So we're moving out of how to code and into how to think about algorithms. So again, this is coming out of the chapter 1 from this textbook. Encourage you to go look through that. You'll get lots more information from that and from the associated videos. But remembering the big picture of what we're trying to do, we're trying to find the origin of replication in E. coli, or really any circular genome. And so how does the cell know how to start replication in the this replication origin region? Well, it has hidden messages. And so what is the hidden message? That hidden message we've defined, remember back to the gold bug problem, as the most frequent kmer in the sequence. Okay. So for a given region, if we find the most commonly repeated pattern of length k, we can find how is that cell identifying the region. Really, what we're doing is finding the DNA binding site, right? This transcription factor binding site. So what we did so far was, if we had this string of text and we were given a pattern, we could count that. That was Rosalind problem number 10. So that's our pattern count function. Okay. Now the next step is in finding our hidden message is, if we're not given the pattern, we just need to count up all the different patterns and find out which one is most frequent, right? So rather than just counting AATTT, we need to count all of the 5mers that are in this text and then return the most frequent one, right? It happens that I'm highlighting the most frequent one here, right? AATTT happens 3 times, so it is the most frequent kmer, or the most frequent 5mer in that region. Okay. So Rosalind number 11 is finding the most frequent words in a string. A different way of saying that, most frequent kmer in a string. So Rosalind is going to give us the text, right, our DNA sequence, and some integer k. So the sample data set is here, right? So it gives us this as the sample text, and then 4, which means we need to find all of the 4mers, and then we need to return the most frequent 4mer in the text in this example. So the general statement, we need to find the most frequent kmer in the text. So how do you approach this as a coding? I had this Sinjini asked me this in class on Tuesday. You know, so far I haven't really talked about how do you start, right? I gave you the pseudocode last time, tried to walk through it a little bit in terms of how to think about it. But now getting at this algorithm, so how do we approach, or where do we start? So I don't jump straight to pseudocode even. I think about, okay, what do I need to do with the information that Rosalind is going to give me? So, right, it's going to give me this sample DNA and the number 4, which is the size of the window, basically. So I'm thinking, okay, I've got this text, and I need to find all of the 4 base pair windows. So just like problem 10, I know how to do a sliding window that grabs every 4 base pairs, right? And the only difference here is that before I was given ACGT and I needed to compare it against the text every time. In this case, I need to sort of catalog every one of these, and I'm going to have to count how many times does each one of these patterns happen in the text. Okay. So already in mind, I know I'm going to have to catalog this, so I'm going to want to make a list, right? So just to start thinking about this, I'm going to have this list, and I've kind of flipped it on its side just so it lines up here, where I can say, okay, I grabbed this window. Now count it. How many times does that thing happen in the text? And right, we have a function to do that. That was Rosalind problem number 10. So if I have ACGT, I can ask how many times does that happen in that string by sending it to my pattern count function. And then basically instead of 0, that will be however many times it happened. So 1, for example. In this case, it happened 1, and then I would scan along. Okay, so that's in mind, that's what I need to do. Okay, and then I just have some notation down here. I would already be thinking, okay, how am I going to code this loop, right? And thinking about, you know, how did we do the sliding window for I in, and then how far did it have to slide? Well, I need to know the length of the text, and then it only wanted to go to the length of the text minus k. Okay, and that's 26, but if I say range from 0 to 26, it's not going to get 26 because it's not inclusive, right? And so I'm already thinking along those lines a little bit. But now is when I would go, okay, I need to outline the program. So the textbook gives pseudocode, okay, which is a sort of a great help for giving you one strategy to do the problem. But often, even I find the textbook's pseudocode a little obscure. First, you have to get used to the notation, but even then, especially if it's not lining up with the way I was already thinking about the problem, sometimes there's some issues in translation. But given the textbook pseudocode, what I would try to do is translate that into English. So what is this telling me? Okay, so first of all, it's giving me this where it's showing frequent words. Let me. Right, so this bit here is just showing me if I want to write this into a function. Okay, just like I talked about in part 1. And I'm going to ignore that at first and just make this code work without turning it into my own function. Okay. So what's this line? It's saying, well, first I need to create an empty list that's going to hold the frequent patterns, because frequent patterns is ultimately what I need to know. And this is really just initializing that variable. Okay, so I'm creating an empty list for that. This one is creating an empty list to hold the counts for each pattern that I observe. So what's this bit? An array of length. So remember, right, this notation. It looks like absolute value of text, but really that's their notation for length of text. So it's the length of the text minus k plus 1. Right, so that's right, talking about this. Right, how long is this list? And then it's our sliding window. So we are going to do this for loop, slide across the text, stop at length of text minus k, right? That's what I was just talking about with that length of text, thinking about how long is that loop? What does it have to index? And then if I'm going along coding, I'm probably going to stop here and put a print statement and see if it prints the right number of times, right? Just like I showed in part 1, I'm going to say print the index of that for loop. So if it's for I in range 0 to length of text minus k plus 1, and then inside that loop, I'll say print I, okay? Just so I see that it's printing 0 to 26, because that's right, that's how many times I know in this example data set I need to get through that loop. Okay, so the next thing is to get the windows. We know how to do that. Except in this case, our window is going to become the pattern. Whereas before we had a pattern and we were comparing that to the window in the text. So hopefully you remember, or you can go back to part 1 and figure out, okay, I know how to define a window. And then I'm just going to make that my pattern. And then I'm going to send that pattern, right? So now that is trying to get my drawing thing here again. Here we go. Right. So I've defined what the pattern is by the window, and I'm going to send that pattern into my pattern count function. And then whatever my pattern count function returns is going to go into that list of counts. Okay, so we'll see how that works in a second. I'll walk through it step by step. Okay, so once that's done, then I need to determine the maximum value, right? So, now I've got a list of counts. I need to know what's the largest value in that. And so this is where I said this is really the only new command. And you wouldn't have to know this, but you can say max, that's the command of any, like a list. There's also a way to do it for dictionaries that I'll show at the end. But if you do max count, it will return the maximum value of that list of counts. Okay, so now I know what the maximum value in my list of counts is. Now, if I loop through that list of counts, that's what this thing is going to do. Right? So I just go from 0 to range of text minus k plus 1 again, right? Same length of loop as before, but now I'm instead of going through text, I'm going through the count list. So I say if count of the current one is the maximum count, then I want to add that pattern to my frequent patterns, and this will make more sense when we look on the next few slides. Then I need to remove duplicates and print it. So I'm basically done at that point. So how does that, look? Thinking about what's happening here. So first time through the loop, right? This is position 0 right here. So that is I equals 0. Okay. And the pattern is ACGT. So the count becomes 1, right? Because count position I, right? So count index I. When I send that pattern to pattern count, it's going to return a 1. So this thing is assigning the 1 to my list, my count list, right? So count is going to be my list. Okay. And then it's doing a loop. So then it's going to, when it finishes that, now I is going to become 1. And so it's going to move over. And it's just going to keep counting. So now I've sort of gone through. So now we're on the 5th time through the loop. So I is 4. Right? I equals 4. Now, when I send TGCA into pattern count, it actually finds it there and over here. And so pattern count returns a 2. So at count, right? So think about, actually, let me, right. So think about what this is. My list count at index 4. That's what this is. Right. So remember, I is 4. That's how it kind of knows where things are going here. So count 4, it's at the start of that window. That equals 2. Okay, so that's what's being assigned over here. Count 4 is becoming the result of pattern count, right? Hopefully that makes some sense. So that's what this loop is doing. It's just going right through, one at a time, shifting over, sending it to pattern count, and then returning the counts. Okay. So boom, gets to the end. And I'll show you why those are highlighted red in a second. It's because those are the things that match the maximum count. Right, so after it gets done going all the way, sliding all the way across, it's counted every pattern. So I've got this list of counts. Now, what's the maximum? Like, which pattern got seen the most times? Well, 3 is the maximum in that list. All right, so now we need to loop through this count list and pull out the patterns, because right, Rosalind wants the pattern, not the number of times. It wants the pattern. Right, if we go back, right, Rosalind's output, it's looking for the patterns, not the number of times that it happened. Okay, so that's that. Now we're going to go through that list, right? So the for loop is going to slide down this count list. And all right, whoops. I highlighted count I here. So what it's saying is if, right, if count, and I'll just give an example, count 5 equals, and then max count is equal to 3 in this case, right? So that's the first time this is going to actually be true. So the first, right, because if this, right, if this is max count 4, that's going to be false. So first time this is true is the first time it's actually going to do anything down here, right? It's the first time it's going to add the text to the frequent patterns, right? So this at count I is where I is 5, that's the first pattern we want to get. So we need to add GCAT to the frequent pattern list. So I've given a hint here on how to do that. Okay, we've had this function append before, back in maybe part 4, part 5. How do you add things to the end of a list? So dot append. So frequent patterns is the name of the list. We're appending the current pattern. So right, what is this pattern? Like, how do we grab that? How would you call that thing? Right, that's text. Five to, well, it's really I to I plus K. Right. I think. So just showing you, right, that's here. And if I want to add the actual pattern, I've got to grab that in this loop and append it to the frequent patterns list. So at the end of this line, or the end of this loop, really, whoops, then I need to remove the duplicates. And so this was the second command that I said is new. So we haven't seen the word set before, the command set. That will get you the unique items in this list. So if I have a list of frequent patterns, and really at the end of this loop, I'm going to have all of these things that are colored red, right? Because they all are going to evaluate as true. And so my list of frequent patterns is going to have GCAT in it 3 times and CATG in it 3 times. Rosalind doesn't want 3 copies of that and 3 copies of CATG. Okay, so I need to get the unique. That's why I need to remove all the duplicates. So if I do set frequent patterns, then it's only going to give me back GCAT and CATG 1 time. And then I just print that. And that should solve Rosalind problem 11. Okay. So once you've coded that, then you should try to solve it using a dictionary approach. Okay. And so the logic is not super different, except that rather than starting out with this list, I'm just going to every time add this to the dictionary, sort of like our word counting problem that we saw in Rosalind number 5. So creating that dictionary of kmers or patterns, that first half of the program is very similar to Rosalind problem number 5. Then the second half is really just how do I get the keys, right? The keys to the dictionary are going to be the patterns and the values are going to be the counts. So how do I get those keys out of the dictionary? Okay. So the only thing that is new, again, is that max. It works on this command, max, and then the dictionary can be whatever the name of your dictionary is. But it does recognize values. So values is a command here. So if I say max of my dictionary dot values, it's going to give me the maximum value that's out of all the values in my dictionary. Okay. So in this example, I'll have each of these as a key, and it will have a value. But if you do it right, like our remember in the Rosalind problem number 5, what we did was say, okay, check, is this word in the dictionary? If it's not in the dictionary, then make it a new key in the dictionary with a value of 1. And then if you see it again, right, so we go get the next one and the next one, and they're all getting assigned a value of 1 in the dictionary. Even this one, the first time, is going to get a value of 1, and it's not going to be until here where it checks the dictionary and says, oh, it's already in the dictionary. So now just make that key have a value of 2. Okay. So once you've sort of generated that dictionary, and in this approach is generating the dictionary and doing the counting at the same time. Once you've done that, you'll need to get the maximum of the dictionary values. Then you have to loop back through the dictionary, and this will be the tricky part for you to figure out, is how do I go back through the dictionary and just get those keys that have the maximum value. Okay. So yeah, that's it. You should work on number 11, and if you're having trouble, then definitely come to class on Thursday, and we'll try to work through some of the coding. Okay. All right, that's it for today.